Good morning. My name is Shariza Fekni, and today I'll be presenting my capstone project titled Customer Churn Prediction using simulated telecommunication data in a deep learning framework. Thank you for being here. The objectives, the primary goal of this project were to predict customer churn using deep learning, build a full machine learning pipeline from raw material to real-time deployment, enable model explainability through Streamlit, integrate SHAP for transparent AI insight, and finally deploy a user-friendly live app for real-world interaction. Several critical design decisions shaped this project. I selected a deep neural network architecture for its ability to capture complex churn behaviors, Streamlit for rapid deployment, and SHAP for ethical model explainability. Libraries such as TensorFlow and scikit-learn were integrated for modeling and pre-processing, and the final app was deployed via Streamlit Cloud to ensure accessibility and scalability. The system was built primarily with Python, TensorFlow, SHAP, and Streamlit using an agile workflow with sprint-based development. Version control was maintained via GitHub, and the code was modularized for future scalability. The model was deployed via Streamlit Cloud, ensuring a smooth and responsive user experience with SHAP explainability layered into the app interface. Now, the next slide here is the deep neural network architecture. This is from my professor's feedback. I added some extra slide, and this one I designed the deep neural network architecture tailored to capture complex churn behavior. Now this on this slide, I have the input layer, the hidden layer, output layer. I also have the regularization strategies, optimizer, and loss function. The model's performance was evaluated using precision recall, F1 score, and ROC AUC. Real-time predictions were enabled through input forms on Streamlit, and SHAP was integrated to ensure transparency in prediction. Features such as catching, early stopping, and input validation were implemented to boost app performance and user experience. Understanding which features drive churn was critical for building a transparent and actionable model. I have top features here, then I have the feedback incorporation. Okay, with the next slide, I have the revisiting decision challenges and outcomes. Throughout the project, several challenges arose. While the DNN initially showed signs of overfitting, introducing dropout and early stopping improved generalization. Integrating SHAP proved technically challenging within Streamlit, but overcoming it significantly enhanced model transparency. The deployment phase revealed performance bottlenecks, which were resolved through Streamlit Cloud optimization. This page shows the GitHub code. This is the deployment and the live app. This is the link to the live app. I'll come back to this later to explain my project. Okay, this is the conclusion, which the final application was hosted on Streamlit Cloud with this source code available on GitHub. The app allows users to input customer data and immediately see churn predictions alongside SHAP-based explainability insights. And I have here the references and the thank you. Now I will share the screen again to show this one here. I share it here to show the customer churn prediction dashboard. And with this dashboard, I have the to predict churn. And here I have the months. I can increase or decrease the amount here. I can increase it here or decrease. The same thing goes with the other values that I have here. Then I can predict churn. In this case, I predict the churn as 49.48%. Then I go to the next tab, which is the data analysis, and this gives the data overview, a summary statistics here, missing values, churn distribution, which is 0 for no and 1 for yes. And I have histogram that could be generated using any of these values from the drop-down box here. I can go to total charges and I get a histogram for that. And this is the correlation heat map. Now, going again to the next tab, reports. For reports, I can generate reports here. Generating this report, I get accuracy value, precision recall, F1 score, ROC, AOC values, as well as sharp features that I have here. And for feedback, user can give a feedback. In this case, I will show you how it works. I give a feedback like that. I can add a comment like very good. And when I press submit button, it will tell me, thank you for your feedback. Now, I will go back to the sharing here of this slide, which is the deployment slide, and I go to the GitHub. If I open this link here on the GitHub, for GitHub, this is what the page looks like with all the values that I put up here, the requirements, the README, and everything is here up on my GitHub page. So that's it for my Capstone project. And thank you very much for your time and attention. And I'll be happy to take any questions. Thank you.